Hello everyone, I am Vikas Godayam from Electronics and Communication Department, MIT Tandapura. Today in this video we are going to learn about microprogram control, which is a part of basic processing units. So firstly, let's learn what is the definition of the microprogram control. In this slide, we are going to know what is microprogram control. The microprogram control is a method of designing a control unit in a computer where a set of micro instructions will be get stored in a control memory and it produces the control signals. It in context with the hardware control unit, it offers flexibility and easy of implementation. This is called microprogram control unit. In the next slide, we are going to know what are the components required for the microprogram control unit. Okay, in this slide, the components required for the microprogram control. There are 5 components. The first component is control memory, which stores the micro instruction. Then comes the MIR, which is micro instruction register, which holds the current information of the micro instruction. As I told you, there is a diagram based on the conditional branch in the previous slide. That is organization of the control unit based to allow conditional branch in the microprogram. There is a word called conditional branch. Conditional branch. Uh, let me define that first. Conditional branch, it happens only when the condition is true. If I check a number whether it is negative or not, if the number is negative, the condition will be get true. If the number is positive, the condition will be get false. The true value will be get added into the PC. This is called conditional branch. There are 7 blocks over here. The first block is instruction register. As you can see in the slide, the first block is instruction register, that is IR. The second block is starting and branch address generator. The third block is external inputs, as you can see in the top uh, right on this slide, top right on this slide. That is external inputs. Then below that condition codes, and comes the clock. Then micro PC, shortly we can sorry micro PC, that is micro program control, shortly we can call it as micro PC. Then below that control store, then comes CW, that is control words. These are the blocks of this diagram. Then comes the explanation. The first point is the starting address generator block of the figure becomes the starting and branch address generator. Then second point, this block loads a new address into the micro PC when a micro instructor instruct to do any task. Third point, to allow implementation of a conditional branch, uh, inputs of this block consist of the external inputs and the condition codes as well as the contents of the instruction register. Third point, in this control unit, the micro PC, that is micro program control, is incremented every time a new micro instruction is fetched from the microprogram memory, except in the following situations. In the previous slide, means in the diagram explanation, fourth point, I told you some of the situations are there. I'm going to discuss those situations in this slide. The first situation is when an instruction is loaded into the instruction register, the microprogram control PC microprogram control is loaded with the starting address of the micro routine for that instruction. The second situation is when a branch instruction is encountered and the branch condition is satisfied, the microprogram control is loaded with the branch address. The third point is when a end micro instruction is encountered, the microprogram control is loaded with the address of the first control words, that is CW, in the micro routine for the instruction fetch cycle. These are the 3 situations. After completing the diagram explanation, let's know what and all the advantages, disadvantages of the microprogram control. First, let's know what is the advantages of the microprogram control. There are several advantages. In that, I had listed 4 advantages. The first advantage is flexibility. The second advantage is simplified design. The third advantage is supports complex instruction. The fourth advantage is debugging. Flexibility, easy to modify and update control logic. Second one, simplified design. It means reduces complexity compared to the hardware control unit. Third one, supports complex instruction, efficient for architectures. Disadvantages of the microprogram control. First one is speed. The microprogram controls is slower compared to the hardware control due to memory access. Second one is control memory size, requires additional memory for storing micro instruction. Third one is initial cost, higher due to the need of additional memory or specialized control memory compared to the hardware control units. Next in the next slide, I am going to discuss about the applications of the microprogram control. Applications of the microprogram control. The first application is control processing units, that is CPUs, used in CISC processors. Second point is embedded system, control logic for specialized task. Third one is digital signal processors, DSPS, micro instruction based control. Fourth one is emulation and simulation, which enables flexible instruction set implementation. That's all about the microprogram control. I think so. I hope so. You learned something about it. Please subscribe and press the bell icon. Thank you.